Hi folks, I have one of these really heavy duty type 4-pole solenoids. They're basically off of large equipment and they're able to handle a lot of current, amperage traveling through it. I mean, look at the size of these contacts. See how big they are? You can just imagine the current that's able to travel through those. But what I wanted to use this for wasn't going to work because the electromagnet that's inside that allows that plunger, this plunger here, to get pulled in when current is put to the electromagnet. This gets pulled inward. No, I'm sorry. Outward. Outward this way. Not inward this way. Outward this way. So by going outward this way, this is the other connecting point. When it goes outward, it's allowing that circuit to be complete, which is closing the contact. So normally this one here is an open contact and I needed a closed contact, but I needed a closed contact in a large solenoid. And they have the small solenoids that are so-called rated for high amperage, but they simply don't withhold and uphold that high amperage for very long. They work fine for short periods of time, but over a process of a long time, they don't hold up very good. They end up burning out. So I had a couple of these, this type, around. You can see one here and another one here. You know, just from over time and who knows whatever reason, they end up going bad. So here's one of the tops where the contacts would be. See how it went bad? So this one's no good. You know, it's garbage. So I kept them around because just figured, you know, may one day they come in handy. So I decided that I'm going to try and make one with this one that's actually a closed contact, not open contact. And what I mean by closed contact, this here plate is already connected to the other two lugs you see, which makes it closed. The amperage is allowed to flow through there. When it's an open contact, the amperage is not allowed to flow through there unless the electromagnet inside, the 12 or 24 volts, is put to it. So I wanted to make it a closed contact. So what I wanted to do, or what I end up doing, is working on the opposite end of it. And I have it here. The opposite end of it. I basically fastened everything on the opposite end of it. So now when the electromagnet is applied to 12 or 24 volts, this here will go this way, upward, which is going to open the contact. And how I did that, I'll show you. I took another one here. This portion here, some ingenuity needed to take place. A little bit of creativity used. But there it is. And then since I had extra ones, I was able to take the right measurement and measure it up and make the cuts where I did. So it's something like that. This edge here and this edge here, I will weld them together to make this permanently on that one. And after I have that welded in place, you can see where the contact's going to be. And I'm going to come in with the cap, the finished product, with the terminals. And I'm going to fasten it where it originally go, like on this one here. So it'll be together something like this. And when it's all in place, now I'll have a closed contact. So for what I need it for, when I apply the 12 or 24 volts to electromagnet inside here, it's going to end up opening that contact, which that's what I want. I want it to open that contact. So I'm going to go and weld it. I'm not going to show you me welding it. And then I'll come back with you and I'll show it to you basically in a complete manner. And I'll hook up a battery to it. And I'll show you the meter, the voltmeter, multimeter, of how it disengages when the electromagnet is fed the 12 or 24 volts. This one here is a 12 volt. But these come in 12 or 24 volt. But this particular one is 12 volt. So I'll be back with you. I'm going to get all this finished up here and bolted together. And you'll see it in its finished stage and you'll hear it working. Well, here it is. I welded this piece to that piece. You can see I didn't solid weld it. There's no need for that. Basically just tacked it. And what I did on this end here is I removed the big posts. They're no longer going to be used or needed. And then the only two posts that are left that make it the 4-post solenoid originally, well, that's the electromagnet, the positive and the negative feed that feeds the coil inside of here that activates and makes that coil of copper wire become a magnet. And then on this end, I removed the small posts, as you can see, that normally the negative and positive feed would go to. And I have the big contacts. So I'm going to show you with the multimeter here. When this touches and makes continuity, you'll hear a beep. So on these two posts right now, because it's a closed contact, there will be a beep. Now when I feed these two posts, the negative and positive, it will engage and I will lose the contact from here, which is leaving it an open contact. And I'll show you. Just going to hook up my alligator clips to the posts. There's one post. Make sure I got the right wires here. Okay, there's that one. And then we have this one here, which will go on to this post. Now this is going to make a loud noise, a big clunk. You'll hear it. That's the electromagnet turning into a magnet, activating that plunger inside, which looks something like this. And when you hear the noise, it's going to be going click down this way, slamming up against this side, the stopper. And then I'll show you that that there is now an open contact. See, beep here. Now this here should be open and there should not be a beep heard. It's open. And that's what I wanted to accomplish when I engaged that electromagnet inside of here. So I'll release it. You hear it clunk again. That's unengaging itself. And there's my homemade closed contact. Not too sure what to call it after that point. It's not really a solenoid anymore, but it kind of is. Just a switch, electromagnetic switch basically, that's going to be able to handle a tremendous amount of current here. So when I want that current to travel to wherever I want it to travel to, I will engage it here, and it will stop the flow of current here. When it releases itself, the current of flow is able to travel. And that's how I needed this one to work. And from that other part that I showed you, these big posts here, I took them out and I have extra, clean them up a little bit. I have extra contacts so that if the contacts inside of here decide to go bad, I can replace them with these ones. Silver contact. So from those two, I end up with a switch that's going to work for me, along with a couple extra contacts. Now I didn't clean this up yet. That's the inner plate that would make contact against these two posts. But this side here, you can see how it turns after it's been used for who knows how long. That's what it ends up looking like. Pretty used up. But the other side is pretty much unused. But here, it needs a little bit of cleaning up. You can see it there. So I'll clean that up and I'll have an extra disc as well. Thank you for watching. Subscribe if you have not. And thank you very much for those that already have.